From my heart and from my hand, why don't people understand my intention?
Welcome to the Fringe Science Report for Monday, March 12th, 2012. The Fringe Science Report is a weekly segment of Rockin with Doc that will explore some of the extremes of science and reality. This week's topics are listening to earthquakes and origami-inspired paper sensors used to test for HIV or malaria. Inspired by the paper folding art of origami, chemists at the University of Texas at Austin have developed a 3D paper sensor that may be able to test for diseases such as malaria and HIV for less than 10 cents a pop. The sensors can be printed out on an office printer and take less than a minute to assemble. Such low-cost point-of-care sensors could be incredibly useful in the developing world, where the resources often don't exist to pay for lab-based tests and where, even if the money is available, the infrastructure often doesn't exist to transport biological samples to the lab. This is about medicine for everybody. One-dimensional paper sensors, such as those used in pregnancy tests, are already common but have limitations. The folded 3D sensors they have developed can test for more substances in a smaller surface area and provide results for more complex tests. Anybody can fold them up. You don't need a specialist. They're easy to produce as well, so the production could be shifted to the clientele as well. They don't need to be made in the developed world. The results of the team's experiments with the Origami Paper Analytical Device, or OPAD, were published in October in the Journal of the American Chemical Society, and this week in Analytical Chemistry. They fabricated the sensor on one simple sheet using photolithography, or simply an office printer they have in the lab. Folding it over into multiple layers takes less than a minute and requires no tools or special alignment techniques, just fingers. If the sample has whatever targets the sensor is designed to detect, it'll react in an easily detectable manner. It might turn a specific color, for instance, or fluoresce under UV light. Then it can be read by eye. They have also engineered a way to add a simple battery to their sensors so that it can run tests that require power. Their prototype uses aluminum foil and looks for glucose in urine. Their estimates that including such a battery would only add a few cents to the cost of producing the sensor. You just pee on it and it lights up. The urine has enough salt that it activates the battery. It acts as an electrolyte for the battery. You just heard a 6.5 magnitude earthquake that occurred the day before on March 10, 2011. No, not a direct audio recording, but a new way of expressing seismographic data. Last year's 9.0 magnitude earthquake in Japan was the fourth largest since 1900. However, because of thousands of seismometers in the region and Japan's willingness to share their measurements with the rest of the world, the Tohoku Oki quake is the best recorded earthquake of all time. This plethora of information is allowing scientists to share their findings in unique ways. An associate professor from Georgia Tech's School of Earth and Atmospheric Sciences has converted the earthquake's seismic waves into audio files. The results allow experts and general audiences to hear what the quake sounded like as it moved through the Earth and around the globe. He said, "We're able to bring earthquake data to life by combining seismic, auditory, and visual information." This research appears in the March-April edition of the Seismological Research Letters. People are able to hear pitch and amplitude changes while watching seismic frequency changes. Audiences can relate the earthquake signals to familiar sounds such as thunder, popcorn popping, and fireworks. Now let's hear what the earthquake on March 11th, 2011 sounded like. What you just heard was the initial 9.0 magnitude quake, followed by hundreds of aftershocks that occurred after the initial explosion of energy. That's it for today's segment for the Fringe Science Report here on the Paramania Radio Network.